Welcome to part 2 of this fascinating problem involving a square with 4 quarter circles in the design shown. In part 1, we created 3 equations linking A, B and C by looking at various shapes contained within this square. Okay, we're now going to solve these 3 equations simultaneously to eliminate first of all C, then B, and find out what A is. And this is how it works. So we're going to start by writing that we're going to subtract equation 1 and we're going to take from that equation 2. So we quite literally subtract the left hand sides and the right hand sides. So we get 4a take away 2a is 2a. We get 4b take away 3b, leaves me with just b. And we get c take away c is 0. So the c has gone. And on the right hand side we've got 400 take away 100 pi. Okay, and I'm going to call that equation that I've just made equation 4. Okay, equation 4. Right, now we're going to create another equation by subtracting from equation 2, we're going to subtract equation 3. Okay, and that will also eliminate C and give me an equation that only contains 2 variables, A and B. 2a take away a is a. 3b take away 2b leaves me with just 1b. And from that, I can see that the c take away c is 0. So that gives me 100 pi, which is the answer to equation 2, if you like, the right hand side of equation 2. And from that, I've got to take away this thing here, which is 400 pi over 3. Okay, that's all in brackets, minus 100 root 3. Okay, now the next step is to tidy this up and simplify it a bit. And I'll just write it under here, a plus b, okay, can be written as, 100 pi could be written as 300 pi over 3, all right? And 300 pi over 3 take away 400 pi over 3 is negative 100 pi over 3. And I've also got minus 100 root 3, which is plus 100 root 3. Okay, so that's simplified it a little bit. And one final thing I'm going to do is swap the 2 terms over so that the minus term is at the end. So it's the same as 100 root 3 take away 100 pi over 3. Okay, and that is equation 5. So we now have 2 equations, 4 and 5, that only contain A and B. The first one contains 2a plus b, the second one a plus b. Now this is really convenient because if I now subtract those 2 equations from each other, I'll just be left with a, and it's exactly what I want because a is the area of one of these 4 shaded sections. So if I now do equation 4 take away equation 5, it's very conveniently going to leave me with just a on its own, because look, 2a plus b take away a plus b is going to just leave me with a. All right, so that's going to give me A equals, now it's going to be this 400 minus 100 pi and from that I've got to take away this 100 root 3, okay, minus 100 pi over 3. Okay, now I'm next going to take out a factor of 100 because each of these four terms has a common factor of 100. So I can now say that A equals 100 times 4, okay, 4 minus, not 100 pi, but just pi now because I've taken out the factor 100, minus 100 root 3, so it's just minus root 3 because the 100's gone, and it's also minus 100 pi over 3, so it's plus pi over 3 because the factor of 100 is outside. Okay? Now, I can tidy that a little bit further because if I've got minus a whole pi and I add a third of pi to it, I'm going to have minus 2/3 of pi. So that is actually equal to 100 times 4 minus root 3 minus 2/3 of pi, or minus 2 pi over 3. Okay? And that's a simpler expression for A. So that's what the area of one of those shaded bits is, A, as you can see on this diagram here. So therefore, the total shaded area is 4A. Okay, well 4A is just simply going to be 4 of those. So instead of 100 times that bracket, it's just going to be 400 times the same bracket. Okay, so it's 400 times 4 minus root 3 minus 2 pi over 3. Okay, and that's going to be the area of one of all four of those shaded parts. Okay, now we're nearly there because what we need is the ratio of the white to the shaded. Well, look, if we know the area of the shaded, we can easily find the area of the white, okay, because the white area is just going to be 400, that's the area of the square, minus the shaded. So the white area equals, I'm just going to write it here as white, and I'll call that W from now on. The white area, W, is equal to 400 minus 4A. That's the area of the square minus the area of the shaded bits. Okay, so the ratio that we want is this. The ratio that we need is the white area over the shaded area. Okay, and that's going to be 400 minus 4A over 4A. Okay, now it gets a little bit complicated when we start putting in the actual expression for 4A, which is this thing here. Okay, now what I'm going to do is write that next to it here. So it's going to be 400 minus 400 lots of 4 minus root 3 minus 2 pi over 3. and all of that is divided by 400 times 4 minus root 3 over minus 2 pi over 3. Okay, so it looks really complicated because you've got this fraction within a fraction, and then of course you've got your fraction line here. Okay, now that can be simplified enormously because we have a common factor of 400 in each term at the top. So we can literally take out a 400 from the top and the bottom, and they just cancel out to give us 1. Okay, so that is actually the same as just writing 1 minus 1 lot of 4 minus root 3, okay, minus 2 pi over 3, and all of that is written again except just without the 1 in front. So underneath that I've just got 4 minus root 3 minus 2 pi by 3. Okay, so I'm now going to simply times everything in the numerator and denominator by 3, and that will clear the fraction. Okay, so it now can be written as 3 minus brackets 12 minus 3 root 3, okay, minus 2 pi. So I've basically taken every term and multiplied it by 3 on the top. So I must do the same to the bottom. So the bottom becomes 12, or the denominator becomes 12 minus 3 root 3, okay, minus 2 pi. So it's stopped me from having a fraction on the top and a fraction on the bottom of a bigger fraction, if you like. We're nearly there, okay, because if you look at that top line, the numerator, you've got 3 take away 12 is minus 9, and then you've got to take away minus 3 root 3, which is plus 3 root 3, and then you've got to take away minus 2 pi, which is plus 2 pi. So on the top line, you've actually got 3 take away 12 is minus 9. I'll put the minus 9 at the end because that's a negative. It's going to be 3 root 3, okay, plus 2 pi, plus 2 pi, and then it was minus 9, and on the bottom it's just as it is there. Okay, so on the bottom of that fraction we've got 12 minus 3 root 3, okay, minus 2 pi. Now if you put that into the calculator, you get 4.76 something, okay, but that answer we've given is the exact ratio. Okay, so what this means is that if you took the area of the white and divided it by the area of the shaded, it's 4.76. In other words, the white area is 4.76 times bigger than the shaded area. And that is the answer to this very complicated multi-stage question. Okay, and that's the end of the video for part 2.